So, you have fulcrum in middle of seesaw. Seesaw? This distance x, this distance 3 feet. You have child 1 here. Child 1. You have child 2 here. Child 2 equal 100 pound. Child 1 equals 60 pound. Okay? Seesaw is balanced, so you need to remember that. Okay? Force of child 1 on seat. Force of child 2 on seat. First thing we will calculate. Okay? Force equal to mass times acceleration. Acceleration due to gravity in feet per second, about -32. Mass is how big child's butt is here. So we have force of child 1, this is the 60 pound child, equals 60 pound times 32 feet per second. Squared actually. But anyway, you get the point. So this is equal to about 1920 negative feet times pound per second square. Wow, I have good math in my head to figure that out. Anyway, F2 equal about 100 pound child time -32 feet per second squared. Okay? So this is about -3200 pound feet second square. Okay, now we see this is force of child 1, this is force of child 2. Now, what you must realize is child 1, child 2 over here, child 1, they are creating a torque on this location here in the middle, the fulcrum. Torque right there. Okay? And torque is defined as R with cross product F or R sine theta times F, where this is the magnitude of R. So it's R is positive or negative, it does not matter. In this case, our angle is made between here and here. These are both 90 degrees, and the sine of 90 equals 1. So we will be crossing out the 90, taking the absolute value away. Our torque is going to equal R times F. Okay? And the torque of child 2 and the torque of child 1 both act on the middle, and they are balanced. It's important to know that they are balanced. So torque of child 1 equals torque of child 2. If we expand this with our definition, we substitute this in. We say radius 1 times force of child 1 equals radius 2, which is 3 feet. So 3 feet times force of child 2, okay? Force of child 2, -3200 pound times feet per second square. So we get -9600, okay? Pound times feet per second square. And now over here we have R1, which is what we want to know, and F1, which is -1920 feet per second squared pound feet per second squared. So we want to divide by that, take it off. So if I have this here, F1, now I'm going to divide both sides so that it comes out, and we just want R1 on the left. So here we're just having F1 on the bottom. F1 is 1920, so I will write it -1920 pound times feet per second square, okay? Now, we're noticing that in order to solve, when we multiply by, oops, I forgot the unit. When we multiply by the 3, this is a feet, okay? So we're going to get feet square here. And so you see that everything here will cancel except the feet square, okay? Feet square will not cancel. Only one feet will cancel. And so the negatives will cancel, and you're going to get that R1 is equal to the simplification of this fraction, this big ugly thing, that is equal to 5, if you don't know. And 1 feet is left. So child 1, the little one, 60 pounds, he is 5 feet from the fulcrum. So this is the picture. 5 feet here, child 1, 3 feet here, child 2. Okay? This is the picture.